All right. So this is just a computation thing, but I want to be sure you understand what you're finding, okay? So this is talking about finding the component of a vector along another vector. So look at that one with the acute angle between them. And the easiest way to think about it is you're kind of dropping a perpendicular and seeing just what that little portion would be. If you think about it, if I drop the perpendicular, I would be saying the cosine of this angle theta is the magnitude over x, right? That's how we would say it, so that's how we get the formula, that piece is the magnitude of u times the cosine of theta. When the angle between the vectors is obtuse, so bigger than 180, when I try to drop my perpendicular, it goes on the back side, right? When I drop this right here, it's not on vector v, it's on the back side of vector v. When that happens, your x will be negative. So when you have an obtuse angle, that x value is going to be negative, showing you that it's on the back side of the vector. So let's see. Here they want the component of u along v. So let's be sure we know what that means. So the angle between u and v is acute, right? So I'm just dropping a perpendicular from u onto v. And what I'm finding is this piece right here. Right? I want to know how long that piece is. You with me so far? So just think about this as a right triangle. And we need to know what that angle is. Notice they've given me 129 degrees and 26. So the rest of that must be 180 minus 129 minus 26. So this angle is 25 degrees. So again, just thinking about this as a right triangle, you can see that we would have the cosine of 25 is x over 17, right? And the formula was the magnitude of u, which is 17, right? Times the cosine of theta. So really, we're using a formula for something we could have done without a formula, right? Just using our normal trig. So 17 cosine 25, nearest hundredth, 15.41. The magnitude of u cosine theta. So again, remember that 15 is just this piece, right? This is 15.41, but that whole vector is 17. On the next one, again, we have an acute angle between, and we're talking about the projection of u on, not the projection, excuse me, the component of u along v. So we need to drop a perpendicular from u onto v. And so what we're finding is just this little piece. So we know the magnitude of u is 19, and we've got to find that angle in there. So it's going to be 180 minus 68 minus 39, right? So this is 73 degrees. So that component, or x, is going to be 19 cosine 73. 19 cosine 73. 5.56. So that whole vector v is 25, but that little red piece of it is 5.56. Let's look at what happens when that theta, when the angle between them is obtuse. So here, the angle between them is obtuse. Remember, we are not talking about this guy out here, right? We're not talking about the angle bigger than 180. We're talking about the angle between them that's smaller, 54 plus 62. So this whole angle here is 116. And we need the projection of u onto v. So, not projection, I keep saying that. We're doing that in a minute, that's why I'm thinking ahead. We need the component of u along v, but to be able to drop a perpendicular, we would have to extend v, right? So I know when I do this, I should get a negative value for x, right? So when I drop my perpendicular, he's here on the back side, which is why we're going to get a negative. And think about the formula. The formula is the magnitude of u, which is 15, cosine theta, which is 116. Well, that angle, since it's obtuse, it's in the second quadrant, right? And cosine in the second quadrant is negative, right? So we're not going to be surprised when we get a negative answer. 15 cosine 116, negative 6.58. And again, what that negative tells me is that it's not on the vector itself, that it's on the back side of that vector. Last one. Let's see. We need to find the angle between first. I know that this guy is 90, right? I have 25. And then over here, this whole thing is 90. So that little piece is 90 minus 53, which is 37. You with me? So this whole guy must be 25 plus 90 plus 37, 152. So the projection, I'm going to do it every time now. So looking at the component of u along v, again to drop our perpendicular, we would have to extend this out. And then we can drop it. And so what we're looking for is this piece right here. So we can say that x is the magnitude of u, which is 15, times the cosine of 152. Negative 13.24. You don't have to draw them. You can just use the formula. I just think it's nice to kind of understand what it is we're finding. Okay?